Hello everyone, I am Dr. Parameshwari, Assistant Professor, Vardhaman College of Engineering, Department of Mathematics. Now today I discuss about the numerical methods and complex variable. In this topic I taken the line integral in complex plane. Now in this first I will explain about the complex integration. Now closed curve, a curve C from A to B tends to C is said to be a closed if the initial point and the terminal point coincides with the terminal point. That is, here C of A is equals to C of B, then this is called as a closed curve. From figure 1, the initial point and the terminal point will be closed, that this is a closed curve. And then if C of A is not coincide with the C of B, then that is C of A is not equal to C of B, then C is said to be an arc, that is figure 2 is an arc. Now simple closed curve. A simple closed curve is said to be a simple if it has no self intersections. A simple closed curve is also known as Jordan curve. Smooth curve. A continuous arc is said to be smooth if it is differentiable at every point. That is, a smooth arc does not contain any corners, that is sharp edges. Now contour. A contour is a continuous chain of finite number of smooth arcs. A closed contour. A closed contour is a piecewise smooth closed curve without point of self intersections. Example, boundaries of circles, ellipse, triangles and rectangles. A line integral of a complex function, and in this the line integral of a complex function, here I taken the function f of z, that is complex function f of z, u of x comma y plus I into v of x comma y, that is the u is the real part and v is the imaginary part. From z1 to z2 along the curve C, and it is defined as line integral along the C f of z into z dz, line integral along z1 to z2, and here I taken the f of z value u plus iv, that is the real plus imaginary, into dz value, and we know the dz value is x plus iy, then dz value we are consider as dx plus idy. Now z1 means z, here I considering as x1 plus iy1, that is the z1 we are the coordinates x1 comma y1 and z2 coordinates are x2 comma y2. That is, here each and every term multiplication, real part here I separated, that is u into dx minus v into dy, that is the real part, and the imaginary part we separated, that is v dx plus u dy. And here note, this parametric equation of the circle z is equals to modulus of z minus a is equal to r, and that is z minus a value is r into e raised to I theta, and this is about the line integral, contour integral, closed contour and the line integral of a complex function. Now in this line integral I will explain one problem, that the problem is evaluate integration 0 to 1 plus I x square minus iy dz along the path. Two paths are given here, y is equals to x square and y is equals to x. That is, here first here I taken the path y is equals to x square. Along the path y is equals to x square, and here we know z is equals to x plus iy, and in this we replace that path y is equals to x square, that is here I will write z is equals to x plus I, and here we have the y value is x square, that is here I replace the y value is x square. This is z is equals to x plus I x square, and if we evaluate this line integral we want the dz value, that is here write dz is equals to derivative of x with respect to x is dx I, and the derivative of x square is 2x with respect to x is dx, and in this if we taken the common dx, that is 1 plus I into 2x into dx. And this is, we are totally converting this integral in a form of x, and in a form of x means here we have the line integral 0 to 1 plus I x square minus iy into dz. Now this integration totally we are converting in a form of along the path y is equals to x square, that is here I will write the coordinates. 0 means here I will write the x comma y point are 0 comma 0, and 1 plus I means here we have the point 1 comma 1, that is write the first term x square minus I into y, I as it is, and y we have the x square into dz. Already we simplified the dz value here, 1 plus I into 2x into dx. Now here we simplify this integration. We are converting this total integration in a form of x. In a form of x means we have the x and the y limits are there. Here consider the x limits, that is 0 to 1, and x square into 1, each and every term multiplication, x square into 1 is x square into I 2x is I 2x cube, minus ix square into 1 is I x square, minus into plus minus, and I into I, here we have I square, that is plus x square into 2x is 2x cube into dx. Now here we have to separate the real and the imaginary part. 0 to 1, x square is the real part and 2x cube is the real part. Separate it, plus I into imaginary part we have 2x cube minus x square, totally integration with respect to x. Now here we have to do the integration with respect to x, that is x square integration is x cube by 3 plus 2 x cube integration is x raised to 4 by 4, this one is the real part, plus I into 2 x cube integration is x raised to 4 by 4 minus x square integration is x cube by 3, having the limits. We are taking the limits of x, that is here right, x is equals to 0 to 1. Now here we replace the upper and the lower limits, and if we replace the upper limit in the place of x1, that is 1 cube means 1 upon 3 plus 2 by 4, that is 1 by 2 real part, plus I 2 by 4, that is 1 by 2 minus 1 by 3 upper limit, and if we replace the lower limit is minus, that is in a place of minus, if we replace the lower limit we will get 0, that is 1 by 3 plus 1 by 2, if we take the LCM and the simplification, 5 by 6 here we get, plus I, and if we take the LCM of this 1 by 2 and 1 by 3, we get 6 and this 1. That is here, if we take the common 1 by 6, we got the value is 5 plus I, and this is the final answer of along the path first one, y is equals to x square, and we have the one more path is given here, along the path y is equals to x, that is here I will explain about the second path, y is equals to x. This is our question. I will write the question here, integration 0 to 1 plus I x square minus iy into dx. Now this integration we have to solve along the path y is equals to x, that is here right, along the path y is equals to x. Along the path y is equals to x means here we are converting the total z plane, that is here we have the z value is x plus iy. We convert this z in a form of x, that is here substituting the y value is x. Now if this is a z value, now here I will consider the dz, that is the derivative of z with respect to x, that is dx plus I, and this derivative is dx, and if we taken the common of this dx, we get 1 plus I into dx, and this one is we are converting this integration along the path y is equals to x. Now here I will substitute this one in our integration. 0 to 1 plus I means here we have the limits are 0 comma 0 and 1 comma 1, x and the y coordinates, x square minus iy. Iy means here we are taken the y value is x and dx, sorry, here we have the dz value is there, so dz value is 1 plus I into dx. Now in this 1 plus I is the constant term right outside. If we take the 1 plus I outside, then we left here 0 comma 0 to 1 comma 1 x square minus ix into dx. That is we are totally converting the integration in a form of x, that is only take the limits are x and y limits are given, we consider as the x limits, that is 0 to 1. Here I will write the x limits are 0 to 1. So x square minus ix into dx. Now here we take in the integration with respect to x, 1 plus I constant right as it is. So x square integration is x cube by 3 minus I x integration is x square by 2, having the limits x is equals to 0 to 1. Now here we replace the first upper limit 1. So if we replace in a place of x upper limit 1 cube upon 3, that is 1 by 3 minus I by 2 upper limit minus lower limit. If we replace the lower limit in the place of x, here we will get 0. That is 1 plus I, and this one is 1 by 3 minus I by 2. Now each and every term multiplication here, that is 1 into this total part, that is here we get 1 by 3 minus I by 2, I into 1 by 3, that is I by 3, and this plus into minus minus, I into I square value minus, that is both if we multiply that we will get plus, that is I into I value 1 by 2. 1 by 3 plus 1 by 2, here we will get the 5 by 6, and minus, if we take the I common, 1 by 3 minus 1 by 2, that is 5 by 6 plus I, if we take the LCM of this, that is 5 by 6, the 2 minus 3, here we will get minus 1 by 6, that is 5 by 6 minus I by 6, and this is the final answer along the path y is equals to x. Thank you.